Text classification. So let's assume you have a piece of text such as this one here. Tinea pedis or athlete's foot is a very common fungus infection of the foot. It often appears between the toes. It can be a one-time occurrence or it can be chronic, blah, 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 blah. Imagine we want to know which medical specialty this piece of text is related to. Is it nephrology, is it neurology, or is it podiatry? Well, we can, as a human, we can clearly tell it is about podiatry, and there's some clear indications here. Foot, about foot and foot, so it's very much about foot. Let's have another example. Kidney failure, also known as renal failure or renal insufficiency, is a medical condition of impaired kidney function in which the kidneys fail to adequately filter, and so on and so on. Which medical specialty does this text relate to? Well, it relates to nephrology. We can tell because we know kidney is about nephrology, or nephrology is about kidneys, so we know this piece of text is generally mostly about kidneys. And essentially, this is a kind of text classification. So text classification is the process of assigning a value or category to a piece of text or a set of text, given a set of values or categories, so given an existing set of values or categories to be used. There are many examples of text classification. So one is topic identification. So for example, identifying if a news article is about politics, sports, or technology. Spam detection is another kind of text classification, identifying if an email is spam or not. Sentiment analysis, so identifying if a movie review is positive or negative, or maybe strongly positive or strongly negative, and so on. Or identifying spelling correction, identifying if a word is spelled correctly or not. And this can be done by matching words to a dictionary, but also looking at words in the position of the words within a sentence. So there are generally two approaches to text classification, and they're related to machine learning. So that's the supervised and unsupervised. In the supervised approach, we have a training set with existing pieces of data and their correct classification. And we use that to develop a model. And then the model is used to attempt to classify a new piece of text. And we have kind of discussed this in the context of machine learning in general. And the unsupervised approaches is an approach to text classification where the model itself finds patterns in the text based on existing logic or rules of the model itself. And this is an example of this, as we have gone over, is the clustering-based analysis, whereas regression is more of a, which we'll talk more about later, is a more of a kind of supervised approach. So in the supervised classification, what usually happens is we'll have a labeled input, so a set of documents that are already labeled, maybe by a human, or somehow we know they are correctly labeled, and then they are fed into a kind of classification algorithm. There are many of them. We won't get into detail here, but there's a classification. There are many classification algorithms. And then this is the training phase. Then this classification algorithm with the labeled input builds a classification model. And then we can feed unlabeled data, and then to see how well our classification model actually succeeded in correctly identifying the correct labels or categories for the piece of text. So this is the inference phase, and it also will require that we require an assessment, a way to assess if whether or not the classification model worked well. So you may need to go back to this unlabeled input and actually assess it to match with the classification model. So in supervised classification, classification models learns on properties or features of that piece of text, and also there has to be a way to identify the importance of these features. So what's going to happen is we'll have a piece of text, and this piece of text or pieces of text or also called documents, will have a set of attributes or features, okay? And these can be like words. These features of a piece of text can be words, but it can also be part of speech, right? So the word, let's say gene, and the word kidney, and so on. But also you can have all the kinds of features, punctuations, a verb, or is it a noun, and so on. So not just words themselves. And then, and we have a class label from the label set. So we have to have a set of labels. So this can be things like, as we said, nephrology, or neurology, or genetics, or what? Let's say you identifying what kind of medical specialties is related to. And we apply the model on new instances to predict the label. So by what the classification model will do, so something like, and we'll talk more about this later, naive Bayes classifier, and there's also support vector machines, or the other popular ones. It will associate how well the words are within a particular, or how many times, how frequent a particular word is associated with a particular label. Remember, we already have a training set with already labeled data. So maybe gene is connected with neurology only 2 times, but gene is connected with genetics, 4 or 5 or 1,000 times. And kidney is connected to neither of these, but it's connected to nephrology. And by identifying these kinds of connections between the features and the labels, the model is developed and then can be used to predict new sets of documents. So in a similar diagram here, what usually happens in this kind of process, we'll have a labeled data set. So this will have a bunch of pieces of text with the correct labels. We'll break up this labeled data set into a training set and into a validation, or first we have the training data set and we have a validation holdout data set. So this is in the training phase. So this is kind of what the algorithm itself will do to improve itself. And it then, after it kind of compares, the algorithm compares itself with the training data set, with the validation holdout data set during the training phase. The model gets built, as we talked about, and then you can use a test data set to test the data, an unlabeled data set. Now, for you to really have a test data set, you need to, for you to assess the quality of the model, you need to have a test data set that is also labeled either before or after. But this is a kind of explanation of the general process in the supervised text classification. So some classification paradigms. When there are only 2 possible classes, we have a binary classification. When there are more than 2 possible classes, we have a multi-class classification. And when data instances can have 2 or more labels, we have multi-label classification. So in general, some questions to ask in supervised learning are, during the training phase, what are the features that are going to be fed into the model? Are these just the words? Are we using tokens? So for example, periods and other characters. Are we using part of speech tags? Are they predictive? And how do you represent these words? So also, for example, are using unigrams or bigrams? So unigram is just a word that is just one term without any space. A bigram is something like climate change. It's a 2-word term. It usually has a space in between. Climate change is might be a very relevant term, but if you just look at it separately, climate as one word and change as another word, you're never going to notice it. So you need to look for the term. You need to have a bigram, and you need to implement this as its own term, climate change, and not just implement it as unigrams, that is just the word climate, just the word change. What is the classification model or algorithm? As we said, there's many of them: naive Bayes, support vector machines, and we may explore some of these more specifically. What are the model parameters? Each of these models have different parameters that may be adjusted, such as how many iterations it will run to identify the best model itself, and things like that. So that's important to recognize too. This is a very complex set of tasks, and we may explore this a little bit next week in a very simple way. And then in the inference phase, what is the expected performance? Once again, how do we measure how well the model predicted the unlabeled data set? How do we measure? Is it the ratio of how many documents it got right, or how many documents it got wrong? And there are different ways to assess this called the model reliability. So that's it for this one, and I'll see you next time.